What's up, everyone? This is LeetCode 36, valid Sudoku. So we have to determine if a 9x9 Sudoku board is valid. Um, Also, I'm going to note, just to point this out, it's asking, we have to find out if the board is valid, right? Notice the problem is called valid Sudoku, not solve Sudoku, right? So make sure you understand that this problem is less complicated than you might think, actually. So only the filled cells need to be validated, right? So basically, we have the Sudoku board, we have filled cells, and we basically need to check if these filled cells follow the rules of Sudoku, which they lay out here, right? So each row, we can't have any repetitions for the numbers 1 through 9. Each column, we can't have repetitions in 1 through 9. And then each 3x3 sub box, right? So this is a sub box, this is a sub box, right? So there's 9 sub boxes, as you can see. In those 3x3 sub boxes, there can't be any repetitions of 1 through 9. Okay. So, if it is valid, we return true. If it's not valid, we return false. Okay. Now, for our approach to this, first of all, we are going to point this out, right? This box is, or this grid is 9x9, right? This board. Right? You see that in the constraints. Okay, so that's actually good for us. Makes the problem a little bit less complicated because our input won't grow. It'll always be fixed. The board length will always be fixed, right? 9x9. Now, how do we know if there's repetitions going this way, that way, and as well as if there's any repetitions in the grids, right? What we're going to do is we're going to have a hash map to solve this, okay? So we're going to say the maps will use the set as the values since the values cannot repeat. What does this mean? Is that for every row, we're basically going to create a hash map, and the key will be basically the indexes of the rows. It could be 0, 1 through, right, all the way up to 8. And basically this, for example, would give you the 0th row. Right, and as we traverse through the entire board, we'll basically check at each given row, and we'll do that by by the key, right? That lets us know what row we're on. If there's a certain value that already exists in the row, we're going to return false because we're seeing it a second time in the row or in the column, right? Because we're also going to use this set for columns as well, right? Like the 0th column. I don't know if that makes sense to you, but basically, right? Like for example, this is just really pseudocode-ish, but right, like when we're traversing left to right, for each row. So in the first row, right, we're adding a 5, a 3, a 7, right? Now let's say in the look at where my mouse is. Let's say in this cell there was a 3. Well, we would go to the 0th row and we see that there's already a 3. So when we add a 3, we say, hey, there's already a 3 there. We're actually not even going to add this, right? Because we'd fail our check because it already exists. So we would return false because it's not a valid Sudoku board, right? When we go to the first row, for example, instead of the 0th row, I'm using indexes here, right? When we go to the first row, we wouldn't use these values because again, the key would be row 1 because we're on a different row, right? And we would go 6, 1, 9, 5, right? And we would do the same process for the columns, right? We'd basically have another hash map where the key is just the actual column we're on. And that's also why the solution is really elegant, is because this grid is 9x9, right? So we won't have any weird edge cases. So it kind of makes this problem a little bit simpler than you might think. Now for the grid, the way we're going to do the grid is that we're going to, because of how truncating works in terms of integer division, where it rounds towards 0, we're basically going to take, we're going to take whatever row we're on, the index. For example, if we're at this 0, 1, 2, right? 2 divided by 3, right? That'll give us 0. When we go to the third, so basically, think of it like this. These subgrids right here, they're technically the 0th index, these are the first index, and these are the second index. And the way we, and the reason we're doing that is because we can pick a particular grid. So for example, when we go to this grid here, right? Let's say we're on some line here. This would be 0, 1, 2, 3. Like, let's say this particular cell. 3. So we do 3, and we're always dividing by 3, right? Because there are three boxes max in each direction. So we're always dividing by 3. Remember, we're doing integer division, so we need to do this. So if we're at this particular box here, or cell, where my mouse is, it would be 0, 1, 2, 3. So it would be 3 divided by 3, which gives us 1, right? So we know that we're at the first index for the sub boxes, so it's one of these boxes here, this one, or this one. Now, how do we know which one we're at? We're going to look at the column, right? So when we're at this one, this is what, column 8, right? 8 divided by 3 would give us 2, right? And again, this is just because of how truncating works with integer division, right? In Python, in any language, really. I shouldn't say in any language because I'm not sure if that's true, but you might implement it slightly different in other languages, but the point is we're doing integer division, right? And so it gets truncated off because we're really rounding towards 0. So we get 1 for the row and 2 for the column. So we know that we're at 1 for the row, so this is 0, 1. Okay, so we're at the first row for the sub boxes or the subgrids, whatever you want to call them. And we're at the second index for the column, so 0, 1, 2. So we know we're in here. So the way this is going to work is we're basically going to keep a hash map for each of these grids, and we're adding values towards that grid. So for example, for this particular example, right, for this 3, right, we would basically have a hash map where the key is this, right? Okay, the key is this. And what does this do? It basically points to this particular subgrid here, and then we add the value 3, right? And so we're saying, hey, we just added a 3 in this sub box. So if at some point, like let's say we have a 3 here, we would know that, hey, when we check the subgrid here, we already added a 3 to the hash map. So if we see another 3 like anywhere in here, we would have an error, right? So that's kind of how it works. It's really not too complicated. It's a little funky and weird, but that's basically how we check these sub boxes, is we're doing the division by 3, integer division, okay? Code is really simple too, so it'll make more sense when you see our code. But really, again, the way our solution's gonna work here is this, okay? So we have a map for the rows, and that's basically going to, technically I think the key should be on the left side here, but I'll just use the colon basically. The row is gonna map to a set of values, right? A set of values. And the column will also map to a set of values. Because the values in these hash maps will be a set. Because a set is a good way to basically check if each value is unique, right? Because if we can't add a 3 if there's already a 3 in the set, right? So yeah, I mean, it's just a simple way to implement this. And then so basically have 3 hash maps, right? And then this one is basically we get the grid doing this, right? And they map to a set of values. Okay, basically right, we're basically checking what values are in each subgrid. That's all we're doing. Okay, now we're going to implement this in, oops, let me do this. Now we're going to implement this in Python. For the Python, or for the C++ video, I'll cut right here, and we'll implement this actually in C++ for that video. Okay, so let's make our hash map for the rows. We're going to say row map. We're going to say default dict set. Remember, we're going to use a default dict because if we're on a new row, right, we just create it when we're adding a value for the actual values that we're adding. That way we don't have to manually add every key, right? So we're just going to use a default dict. Remember, these values are basically set. We're using a set for the values because they have to be unique. Because they can't repeat, right? That's literally in the problem statement. We're going to do the same for the columns. So we're going to say default dict set, and again for the subgrid stuff. we're gonna say default dict set. Okay, and remember the grid is 9 by 9, so we're gonna say this or in range. You can do n and set n equals to n above. It doesn't really matter. That's more appealing visually to you, but we're just gonna do 9 by 9 because this board will always be 9 by 9 in the constraints, right? So we're not going to run into any issues by hard coding that value in there for our for loops. Okay. So first of all, remember, we're only validating cells that are filled in. So empty cells are basically represented in the input by a period. So if there's a period as we're traversing this grid, then we can just ignore it basically and keep going forward in our for loop. So in our nested for loop. Okay, so we're just going to continue. If it's a period, right? We don't care about it. Now, when we're in the else statement, right, as we go along, and let's say we hit a number, right, meaning it's not a period, it's not an empty cell. What does that mean at that point? Well, we need to check if that value is either in any row, in the current row, or in the current column we're on, because it could be the case that it violates that, as well as check if we've already seen that number in the subgrid already, right? So we're basically checking, has it been repeated? Or is this value that we're on a repetition, which again would invalidate the rules of the game. Okay, so we're going to say if we're going to say board that particular value, let's get the particular value, and we're going to say row map r. So the current, we're going to the current row and we're checking, is this value already in the hash map for the current row? Meaning, have we already seen it in this row? Right? If yes, we would enter the if statement and we have to return false, right? Again, that's for the row though. We're gonna have to do the same for the column. So we're gonna say board, let me move my mouse, board RC in, and we're gonna say call map C. Okay? Or, and now we're gonna do the subgrid thing. We're gonna say, we're gonna get the value. Okay? We're gonna get the value that we're on. And we need to check, is that value in the, have we already seen that value in the current subgrid? How do we check that, right? We're basically going to check subgrid map, right? And remember, what is the key in the subgrid map? The key is the indexes for the particular actual grids, right? So for example, 0, 1 would be this grid. 1, 1 would be this grid, right? So so the key for the subgrid map is a pair of values, right? And we're gonna get that by taking the current value we're on, divided by 3, C divided by 3. The reason we do this, in case you're lost, is because if we're on this 3, right, this particular value, to get the subgrid we're in, we're going to take the row in the column that it's at and divide by 3, and we get the entire grid basically address, right? That's what we're doing, which would be the key that we put into the subgrid map hash map, okay? And that's how we basically check the current subgrid we're on. And basically, if we've already seen that in this, if we've already seen this 3 in the subgrid map, because let's say it was right here or something, where my mouse is, if it was right here, when we get here, right, we have another 3 in the same subgrid, and of course we have to return false because that would violate this rule right here. Okay, so that's pretty much it for the checking. When we would have any errors. If we don't have any errors, we don't return false. What does that mean? It means we've never seen this value in the rows, in the columns, or in the subgrid. In which case, we have to add that to our hash map, okay? For our hash maps. So I'm gonna say row map r, and then we're gonna add what as a value? We're gonna add the current value. Now for the column hash map, for that particular column that we're on, we're gonna add that value as well to the hash map. So I'm gonna say board RC. As well as for the subgrid, okay? So for the subgrid, how do we get the current subgrid that we're on? We're just gonna do r divided by 3, c divided by 3 to do the truncation, right? because we're doing integer division. And then we're going to add what? The current value that we're on, the current cell value. And we do that by doing dot add board RC. Okay. And if we exit this entire for loop, it means that the entire Sudoku board is valid because we never return false. And so at the end, we just return true and we have a valid Sudoku board. And we're going to run this and boom, there you go. It's accepted. Anyways, I hope this helped. A bit of a weird problem. Wouldn't say it's too difficult, but it's definitely weird. Yeah, I hope this helped. I'll see you in the next one. Peace out.